Mr. Hissner here, and today we're going to be looking at finding missing angles using trig functions. For the past several days, for the past week we've been using trig functions to find missing side lengths, missing segment lengths of a triangle. So we were given an angle measure and we had to find the side lengths. Now we will be given the side lengths and we will need to find the angle measure. This will require what is called inverse trig functions or arc trig functions. So let's just look at these. So for example, we have our trig functions as sine, cosine, and tangent. Inverse trig functions would look like all of these to the power of a -1. Also, sometimes they are written as arc sine, arc cosine, and arc tangent. So yeah, these are the different ways that we can think of our trig functions. However, what an inverse does is the opposite of multiplication, or the opposite of addition, is subtraction, right? So if you can take 1 plus 1 is 2, and then the inverse operation, so let's think of this as like our inverse. So 1 minus 1 would be 0. Maybe that's not a good one. It undoes the stuff, right? The inverse operation, so if this is x plus 2 is equal to 8. We use the inverse operation to undo, to kind of get rid of, to cancel out. This is an inverse operation. So minus and plus are the inverse operations of each other. And then furthermore, let's actually make this a 3. So then if this was 3x, this is multiplication here, right? This is 3 times x. And so the inverse operation of multiplication is division, right? So again, this would be an inverse operation here. 3 times multiplies by 3 on the top, divides by 3 on the bottom. This is an inverse operations. So the idea here is that we are using these inverse functions. We had one also that was like when you square rooted the square, these two things canceled and you were left with just x. So we have some inverse operations already in our arsenal. And today we're going to continue on with these. So let's just look at what we have here. Remember, we have sine of an angle is the opposite over the hypotenuse. We have the cosine of an angle is the adjacent over the hypotenuse. And we have tangent of the angle is the opposite over the adjacent. And again, this is at least the 50th time I'm writing this down, so you should of course have these somewhere. And so let's look at what we have here. Here's our angle in question, and we want to know what two pieces do we have. Well, this across from here is going to be the hypotenuse, of course. Across from here would be the opposite, which is not in the equation here. And then finally, 8 is our adjacent side. This is the side that is making the angle as well. So we have our adjacent and the hypotenuse, so we're going to have to use cosine. So what would this look like? Well, this would be cosine of x, because we don't know what the measure is equal to the adjacent 8 divided by the hypotenuse 11. And again, this is a number. We don't know what number it is, but we know that it is a number, and so we can cross multiply. 8 times 1 is 8. Cosine of x times 11. I'm just going to keep the junk in the trunk, and so I'm going to put it in the back. Now, why is this important? Well, actually, you know what? Okay, what am I going to do? Let me actually restructure this. This might be more helpful to see it like this. I'm just going to give a little space here, 11 times the cosine of x. So the idea here is that we have to solve for x, right? What do we need to do? Well, we need to isolate the variable. We need to get x all by itself. You know what? We'll do that first. We need to get x by itself, so let's divide both sides by 11. Okay, so we have these cancel, and so we have 8 over 11 is equal to the cosine of x. Now I'm going to leave a little bit of space. So what do we need to do? Well, we need to somehow free x we need to free x. This needs to be free from these parentheses. So what are we going to do? Well, we're going to actually use the inverse function. We're going to multiply both sides by cosine inverse. And what that does, just like if you were going to multiply 2 times 1/2, you get the multiplicative identity, or if you're going to do 2 plus a -2, you get the additive identity. So what this is essentially doing is that it's just kind of canceling out cosine and cosine inverse. So let's see what that would look like. Here we go. Well, I'm going to have to use the inverse function. Notice how I'm pressing inverse and it's bringing up these inverse functions? So I'm going to do the inverse of cosine of 5. It's just 5. Whenever you do the inverse of a trig function, let's do the inverse of tangent. Let's clear this. Let's do inverse of tangent of the tangent of 14. It's just 14. The inverse takes away the trig function. It's basically like dividing by 2. If it's being multiplied by 2, it just reduces it to a 1. Okay, so we have the cosine inverse, the arc cosine of 8 divided by 11. Oh, it's a number. It's 43.3. And so all we got to do back here is say, okay, well, these two canceled, so we're left with just x. And that's equal to 43. Man, 43.3. So again, the trig inverse functions cancel one another out. They are opposites of each other. They remove the inverse and they leave you only with the x. The thing is, though, you need to do it to both sides. Let's look at this next one. So here we have our opposite side, we have our hypotenuse, and oh, here, look, is the adjacent side. So this one, again, looks like it's going to be cosine. Cosine, again, I have these all written up there. So we have the cosine of x is equal to the adjacent over the hypotenuse, 1823. And again, we can cross multiply. 18 times 1 is this. 23 times the cosine of x. We have to divide both sides by 23. Hopefully you can sort of see a pattern here, 23. So now we have 18 over 23. Actually, let me do this over, run into the next problem. 18 over 23 is equal to the cosine of x. So we need to multiply both sides by the cosine inverse. So these two cosines cancel out, and we're left with x is equal to the cosine inverse of 18 divided by 23, 18/23. So let's see what that would be. Inverse cosine 18 divided by 23, enter. It looks like 38.5. Oops. And again, these problems are very predictable. You may even see right away that there is a very clear issue with this. And in fact, let me see this next problem. I'll show you. I will show you the shortcut right now. I'll show you the shortcut right now. So here is our opposite side. Here's our hypotenuse, and then this would be our adjacent side. And so this is going to be tangent, opposite over adjacent. So tangent of x is equal to the opposite over hypotenuse, so 7/5. And in fact, we can take the inverse of both sides right here. Notice that I don't have to do a cross multiplication. I can just cancel these out right here. So this reduces right to x, and this is x is the tan inverse, the tangent inverse of 7/5. Tangent inverse, inverse. Tangent inverse of 7/5. Looks like 54.5. So again, guys, what we're doing here is we're using our inverse functions, And again, I think this last example, if you picked up on it the first 2 times, all we really did was do-si-do these numbers around, and there was no difference between what we were written here and what's written here, or what was written here and what's written here. The idea is that whenever you have to solve for x, you can just set up your ratio and use the inverse trig function on both sides, and it's a one-step equation. All right, thanks for watching, guys.